Is it possible to educate a router regarding how to forward IP packets? The answer is yes. And we're going to investigate that and demonstrate that in this nugget. Let's begin. In our last nugget together, where we implemented IP addresses on the routers and on PC number 2, we had a little issue in that the router number 2 didn't have reachability back to this network. It couldn't reach 10.1.0.1. We tried pinging that IP address of router 1 and we could not get there. And in that nugget, I mentioned it was due to routing. The routers only know by default about networks they are directly connected to. So if we went up and asked Mr. Router 1, we said, hey, Router 1, what do you know how to reach? He would say, I know how to reach network A, which is 10.1, and I know how to reach network B, 10.2, because, says router number 1, I am directly connected to those networks. I live on those streets. It's like having a house with 2 driveways, and that's referred to as a directly connected route or a directly connected network. And that is one way of training a router on how to reach a network. You give it an IP address on a network and poof, that router believes it's connected to that network. And the information regarding those directly connected routes are put in something called the routing table of the router. Think of the routing table like a giant map of how to get places. Every time the router gets a packet, needs to forward it, it consults its routing table and says, okay, how do I forward this packet to get it towards its final destination? And if it doesn't know, if it doesn't have any information in its routing table, it just gives up. And it drops that packet, and in some cases, it'll go ahead and give a response back to the source. Like, for example, if computer 2 tried to reach the internet and router 1 didn't know how to get there, R1 might send a message back to computer 2 saying, you know what, sorry, I don't know how to get there. I'm so sorry I dropped your packet. And that response back from router 1 back to computer 2 is done with a little management protocol called ICMP, which we'll talk about more in a separate nugget. So next our challenge is, how do we train routers on how to reach or forward in the direction of networks that are not directly connected? And we have 2 primary options, and they are right here. We can statically configure what is called a static route. It's like hard-coded instructions. So in the case of router 2, which has no knowledge by default of how to reach the 10.1 network, that's network A over here, we could configure a static route on router 2 that says the following. Dear Mr. Router 2, if you need to forward a packet to the 10.1 network, the next hop, which is a fancy way of saying the next device in the path to get to that network, is, and we would go ahead and give it the IP address of our firewall, which on network D would be 10.4.0.100. So that route would then be added to the routing table because of our static route that we added to router 2. And if router 2 ever needed to forward a packet to the 10.1 subnet, it would know that the next hop is the firewall, at which point it would go ahead and re-encapsulate the IP packet into a layer 2 frame that had the layer 2 address of the firewall. And if router 2 didn't know the layer 2 address of that firewall, it would go ahead and do an ARP request, cache that information, encapsulate the frame, and then it's up to the firewall's job to forward it the rest of the way. So the world of IP at layer 3 is like hot potato. You get a packet in, you look at it, you make a forwarding decision, and you move to the next packet. And you do it as quickly as possible. And in the event you don't know how to forward a packet, you drop that packet. Now in the case of router 2, it would be a really big pain to do static routes. For example, we'd have to have a static route that says how to reach network F, and how to reach network C, and how to reach network B. However, router 2 is directly connected to network D, network E, and network G, so it's no problem with those 3, but it would need static routes for the rest. Also, what about the networks that are out on the internet? we certainly are not going to statically configure manually configured static routes for each and every network that exists on the internet. So we have a special type of route, and it's called a default route. It looks like this. If you ever see a route with 4 zeros for the IP address and 4 zeros for the mask, that, my friends, is a default route that we can go ahead and place, again, in the routing table of the router. And when I think of default route, even to this day, I think of Star Wars. Remember Princess Leia saying something like, "Help us, Obi-Wan Kenobi, you're our only hope." That's kind of like what a default route is. It's a last-ditch effort. If it can't find anything else in its routing table to use to forward a packet to its final destination, it's going to sigh. You can think of it sighing, saying, I got to use my default route. And then it will go ahead and use the default route. And that default route is going to specify what that next hop is. So in the case of R2, it's very likely that if we were going to configure a static default route, we would tell R2 that the default route would be the IP address of .1 on the 192.168.1 network, which is the service provider for everything out on the internet. So here's what I would love to do with you right now. Let's configure static routes on router 1, router 2, and also the branch router out here. And on router 1, we'll tell it to use the firewall's IP address as the next hop for its default route, which we'll configure statically. The firewall, once again, has already been pre-configured by the firewall team, so that's already in place. On router 2, we'll configure a static default route that says to use the service provider as the next hop. And for the branch router out here, we'll tell the branch router to use R2 as its default route. So anytime these routers have a packet they need to forward and they consult their routing table, if they don't have an exact match in their routing table for the network this packet is destined to, they'll go ahead and use the default route and forward the packet using that default route in their routing table. So we're going to start our journey here on R1. Now, again, the syntax, the exact syntax isn't critical for a Network Plus. The concept, however, is important to get. So here on router 1, let's go ahead and do a show IP route on a Cisco router. That is the command to look at the IPv4 routing table. And in Cisco's iOS version 15.x, they also show with this output something called a local route. And to clean that up just a little bit, I'm going to use the command show IP route, a pipe symbol, and I'm going to say please exclude any output that has the capital L in it. And that'll just make the output more simple for us to go through and work with. So from router 1's perspective, it currently knows how to reach the 10.1 and the 10.2 networks, and that's networks A and B because it is directly connected to both of those networks. And at the moment, router 1 does not know how to reach any networks outside of those two networks that we see right here. So here on router 1, let's go into configuration mode with the command config space terminal, and we'll configure a static default route using the command IP route quad 0 space quad 0, and then the next hop of 10.2.0.100, which is the firewall. So there's our quad zeros with 3 periods in between. These are dotted decimal. There's the mask as 4 zeros. And again, that's the special code for default route. And the next hop is 10.2.0.100, which is this interface on the firewall right here. Now, just because we're going to use the firewall as our default route, it doesn't mean the firewall automatically knows how to forward everything. Every device in the network needs to be configured to make correct forwarding decisions. And it just so happens for us that the people who configure the firewall, they've already configured that for us. And it's very likely, if we looked at the configuration of the firewall, it would very likely say that its default route is to forward packets over to router 2. And that's why, my friends, it would also be a very good idea for us to configure a default route on R2. So if it receives packets for the internet, it also will know how to go ahead and forward those packets. So before we leave router 1, let's get out of configuration mode and do a show IP route once again. And you'll notice now in the output of our routing table, it's showing this default route. It's also indicating over here that it was learned statically because it was a statically configured default route. And it says if I get a packet where I don't know the destination of how to route it, I will go ahead and forward it to 10.2.0.100, which is the firewall's IP address. Great, router 1 is configured with a static default route. Let's go to router number 2. On router 2, let's do a show IP route here as well. Again, I'm going to exclude the output that has the L in it just to make it a little bit more readable. And as we look at the routing table here on router 2, it has 3 directly connected networks that it knows about. The 10.4, which is network D, the 10.5, which is network E, and the 192.168.1, which is network G. So if we want to modify the routing table by adding a static route, and more specifically a default static route, we'd go into configuration mode with configure space terminal and use the command IP space route quad zeros space quad zeros, the next hop of 192.168.1.1, and then we can get out of configuration mode. So once again, if we do the command show IP route to look at the routing table, we're going to see the directly connected networks, and we're also going to see the static route, which is the default route, using 192.168.1.1, which is our service provider, as the next hop. And we could actually implement additional static routes besides the default route. We could add a static route, for example, that told R2 to get to the 10.1 network specifically to go ahead and hand it to the firewall as the next hop. But what you're going to find is that in most environments, using static routes for all the detailed routes is really tedious, takes a lot of effort, and anytime there's a change, we'd have to go back and manually change static routes, which is too much administrative overhead to do. Too much burden on you and I, the administrators. So we have some alternatives to using static routes anywhere. However, using a default static route is a very typical and common thing to implement. So we have one more router to do, and that's our branch router. So let's go out to the branch site. And we'll go into configuration mode on the branch router, and we'll use the command IP route. We'll specify the default route, and we'll say that 10.5.0.2, which is router 2's IP address, is going to be the next hop. So anytime we need to forward packets, says the branch router, and we don't have a more detailed route in our routing table, we're just going to ship that packet off to R2, and hopefully, says the branch router, R2 knows how to continue forwarding that packet. We don't have any guarantees. We're just hoping that the neighbor that we're handing this off to can forward the packet. So on the branch router, if we do a show IP route here, it should have any directly connected networks as well as its default route. So at the moment, it's got the 10.5 network, which is the serial link between itself and R2, and it also has the default route that says it should use R2 if it ever needs to forward a packet out to the internet. So with these default routes in place, let's go down to router 2 for a moment. And let's verify that router 2 can ping an internet resource. I like using a Google DNS server because it's usually available. So we'll do a ping out to 8.8.8.8. And sure enough, router 2 has successful connectivity out to the internet. It's using the default route to reach the 8.8.8.8 address. Because it doesn't have a more detailed route in its routing table for 8.anything. So it used the default route, handed the packet off to its service provider at .1, and the service provider, fortunately, knew how to forward it the rest of the way. So next, let's see if router 2 can ping the 10.1 network. In fact, let's try to ping 10.1.0.1. That's router 1's interface address on 3/0. And we're getting period, which is timing out. We're not getting a response back from anything. So I think the technical term for that is bummer, dude. Why isn't it working? R2 cannot ping over to the 10.1 network, or at least it's not successfully getting a response back. So if we look at the routing table of R2, it doesn't have a specific route to the 10.1 subnet, which means it's using its default route and sending the packet out to 192.168.1.1 for routing. And that's going out this way. So unless our service provider has some magical means of getting to the 10.1 network, that would explain why we're not successful in our ping. It's very likely that the service provider does not itself have a route back to our internal 10.1 network. Even if it did, even if the service provider said, yeah, hand it back to R2, when it gets a packet to 10.1 based on its routing table, it would forward it back to the service provider. And that would just go back and forth and back and forth. And that's what's called a routing loop. So a layer 3 routing loop is when two routers are handing the packet back and forth and back and forth and back and forth, each of them following the instructions that they have in their routing table on how to forward a packet. And as you can imagine, a routing loop is a pretty serious problem because it's consuming a lot of resources by the network devices, it's consuming bandwidth, and the packet is not getting to its final destination, which of course is an additional problem. We could also verify what R2 is going to do with this packet by using a Cisco IOS command called traceroute. Now this command is very similar to traceRT on a Windows platform. And on a Cisco router, the traceroute command will simply show us the path that the packet is taking. And I'm going to go ahead and hit Control-Shift-6 to stop this output on the Cisco router because it's not getting any further. And what this indicates is that our first hop was 192.168.1.1, which is the service provider, and then it's very likely that our service provider just dropped it because the IP address of 10 anything is not a destination on the public internet because it's an RFC 1918 address space, the 10 is. And as a result, we are forwarding in the wrong direction R2 is based on our current routing table. In this nugget, we've identified a couple of ways of putting routes in the routing table using directly connected networks that go into the routing table, as well as manually, statically creating routes that can go in the routing table. The example we used was a static default route. Now, there is a much more efficient way to train a router regarding how to reach multiple networks, and that is to use a dynamically configured routing protocol, which, my friend, you and I will cover in the very next nugget. So until the next nugget, I hope this has been informative for you, and I'd like to thank you for viewing.